In this portion of my demonstration, I will execute queries um, to get the answers to the questions which were posed in task 1. As I explained in my paper, I'm using Hive SQL, which is a dialect of SQL language, to get the answers to the questions posed in this task. So for example, I will go ahead and copy the SQL statement for group 1, question 1 query, and I pasted this to my terminal. And once I hit enter, what will actually happen is you will see that a corresponding MapReduce job is created and will be executed on the Elastic MapReduce cluster. So obviously, I'm copying and pasting the SQL statements here just for purposes of the demonstration. I actually have automated scripts that execute all of this and insert the output into the DynamoDB. But rather than me showing you sort of the automated process which hides a lot of details, I'm actually showing you probably the most exposing part of this process so that you can see the queries and you can see the output produced by the MapReduce tasks. Now, most of those queries run very quickly, 60 seconds or so, but to reduce the time that you have to spend examining my task, I will be pausing the recording, but you should be able to see all of the questions, all of the queries, and the outputs produced by the MapReduce tasks. So I'm going to ahead and pause the video for now. So I'm continuing with question 2 from group 1. Question 3 from group 1. Question 1 from group 2. Now, question 2 from group 2. Question 4 from group 2. Now, question 2 from group 3 is a bit special. I needed to implement a shell script that feeds different parameters for the X, Y, Z, and the daytime parameters into the SQL statement. So let me show you first the SQL. So as you can see, the SQL statement is parameterized. So basically for each subquery in the 3.2 query, the variables such for the X, Y, Z, and day and month will be fed into the SQL statement by the shell script. The reason that I needed to integrate with the shell script is because unfortunately Hive SQL at the moment does not have the concept of loops, unlike Microsoft Transit SQL or Oracle SQL. So therefore I needed to do some integration between shell and the Hive. So let me show you very quickly the shell. So as you can see, the shell actually has input parameters that are fed into the SQL script. So for example, there are, you can see arrays that represents the X basically the first leg of the origin, Y being the the destination of the first leg, etc., etc., and then of course the date of the first leg, date of the second leg, etc., etc. So all I need to do is really just run the shell script, and this will in turn execute the query with the right set of arguments. Um, the interesting part, you will see how quickly this gets executed, and the reason for that is because the data was partitioned specifically to optimize for this very scenario. As you remember, if you may remember from my paper, I partitioned the table on month and year and month. Therefore, it is extremely easy for Hadoop to read only the data that is actually needed, because all the queries center around 2008. So only a very small subset of data that actually needed to be read from disk and basically processed as part of the MapReduce. So as you can see, the queries take on average 8 seconds or so. So we'll actually have no choice but let it run, because it will run off the screen very quickly, and I wanted to make sure that you see all of the output produced by this script. One more note on this 3.2 question is one of the subqueries I was not able to produce the result because I was not able to extract the zip file for the December of 2008. I had some problems with unzipping that file, and I know there was some discussions on the forum as well. So I do not have answer for that specific input. So as you can see, for some combinations, there are quite a few options for Tom to take. In some cases, it's really just one option. But nevertheless, you can see that for pretty much all of the destinations, for all of the XYZ, there was an option for Tom to take, and most of them actually have a pretty good on-time performance, historical performance. And that's it. The script completed, and this completes this portion of my presentation.